Hi everyone. Today we are going to see the top physical chemistry questions which were repeatedly asked and what are the questions we are expecting in this year JEE Advanced 2025. So in today's session I try to cover the chapters which are not in JEE Main but they're in JEE Advanced also. So please watch throughout the video and let me know if you have any doubts on the comments. Okay, let's get started with the first question. Consider Bohr's model of a one electron atom where the electron moves around the nucleus. In the following, list 1 contains some quantities for the nth orbit of the atom and list 2 contains the options showing how they depend on n. Okay, so the question is that we have to find out the correct combination of list 1 and list 2. Cool. So let's start solving one by one. Let's check. The first they have mentioned radius of nth orbit. Radius which is equal to r 0.59 by z into n square, isn't it? So this is z into n square, which clearly indicates that r is directly proportional to n square, which means that holds true for T. Cool. Then angular momentum of the electron in the nth orbit. So angular momentum we know mvr is equal to nh by 2 pi, right? So angular momentum mvr is equal to, which is directly proportional to n, right? So which means 2 to s, okay? And then kinetic energy of the electron in the nth orbit. So kinetic energy, what is the formula? Ke equal to 13.6 into z square by n square. So n kinetic energy and n is inversely proportional, which means I can write it as n to the power minus 2. Let's check with the list 2. So n to the power minus 2 is there for P. Okay, then fourth one, potential energy of the electron in the nth orbit. So potential energy P equal to minus 2 into 13.6 into n square, z square by n square, isn't it? So which means potential energy is inversely proportional to n square, where I am writing it as n to the power minus 2. Okay, so which of the following options has the correct combination? So 1 to T, 2 to S, 3 to P, and 4 to P. Okay, 1 to S, it's not right. Okay, 1 to T. Okay, so which makes it right answer? 2 to S, right? So that is not right. And 1 to P is also not right. 2 to Q is also not right. So option A is the right answer to this question. Okay, so you have to know all those formulas, then only you can answer to this type of questions. So please pick up the pace for formulas. Then the second question is also from atomic structure, but this is an integer type. The electron in an hydrogen atom undergoes a transition from an orbit with quantum number of Ni to another with quantum number Nf. Okay, Vi and Vf are respectively the initial and final potential changes of the electron. Okay, if Vi by Vf equal to 6.25, the only value they have given, that is 6.25 only. So the potential energy changes is our clue point. They are asking for smallest possible Nf. Okay, so we know that potential energy, which is equal to Kze square by R. R is radius. So R is equal to, radius equal to 0.529 n square by z, correct? So we are going to compare it in the way Vi by Vf, which is inversely proportional to radius. So I am taking that as R2 by R1. So R is directly proportional to n. So which will be n2 square by n1 square. So Vi by Vf value is given as 6.25. So which makes n2 square, n2 by n1. Okay. So which makes n2 by n1. n2 by n1 only, which is 6.25. Okay. So right? So if I'm taking the square root so which makes it n2 by n1, n2 square by n1 square equal to 6.25. So n2 by n1 which is equal to root of 6.25, which is nothing but 2.5. Okay, so n2 by n1, 2.5 means 5 by 2. So which can be written as n2 is 5 and n1 is 2. Correct? So n2 value, that is nothing but the nf value, that is 5. Okay, so answer to this question is 5. Moving on to the next question. This question is from surface chemistry, that is a MSQ type question, more than one correct. Let's see the question. When O2 is adsorbed on a metallic surface, adsorption is something different from absorption. Okay, so that is forming a layer. Okay, electron transfer occurs from the metal to O2. The true statement regarding this adsorption are, okay, so metal to O2, the electron transfer is happening. So that can't be a Physisorption, that must be a chemisorption, right? The electrons are involved. So that will be chemisorption, not Physisorption. So option A is not correct. Then, in case of chemisorption, it is an exothermic heat releasing process. So heat is released. So this can be of right answer. Then occupancy of pi 2p of O2 is increased, obviously. The metal to O2, electron transfer is happening. So O2 gains one more electron, means pi 2p will get one more electron, right? So that will get increased. Then bond length of O2 is increased. Bond length of O2 is increased. So what will happen? O2, that is having the bond order 2. So the bond order is inversely proportional to bond length. Correct? So bond order increases means bond length decreases. Okay. So if I'm adding one more electron to anti-bonding pi star 2p orbital, what will happen? The bond order will be decreased so that the bond length will be increased. Correct? Are you getting my point? So the bond length will be increased. So which makes B, C, D are the correct statements. Moving on to the next question. The given data are the graph. These four graphs represent the general trends observed for different physisorption and chemisorption processes under mild condition of temperature and pressure. Which of the following choices about these four are correct? Okay, again this is an MSQ type. So let's analyze the graph one by one. Here I have the first one, that is amount of that gas absorbed versus temperature, where the pressure is constant. Okay. This question is again from surface chemistry and this is also a MSQ type. Oh. So these are the options given, which is right. Cool. So we have to analyze the graph and tell us which of these are correct. Okay. So first let's see the first graph, which indicates as the adsorption is getting decreased as temperature is increasing. So which clearly indicates this is a Physisorption graph. Okay. Then the second one, what happens? The temperature is increasing, so the adsorption is also increasing. Adsorption is increasing as the temperature is increasing, which is a chemisorption. Okay. Then the third one, in first two conditions, the pressure is constant. In the third one, pressure is not constant, pressure increases. As pressure increases, so the amount of gas adsorbed is also increases, but it is at a higher temperature, the adsorption is high. No, that won't be good. So that at higher temperature, the adsorption is getting decreased. No, that won't be possible. This is not chemisorption or Physisorption. Right. Then the fourth graph indicates the chemisorption because It is explaining the bonding system, right? The potential energy and the distance of the molecule from the surface. So the attractive force dominate up to some point. After that, what will happen? That started repelling each other. Okay, so as we are moving forward, the repulsion will get dominated. So this can be of chemisorption. So let's see the options and we'll decide. So first one is physisorption, second one is chemisorption. This is right. First one is physisorption, third one is chemisorption. No, this is not. Fourth is chemisorption, second is chemisorption. Okay. Fourth is chemisorption, third is chemisorption. No, this is not right. So which means A and C are the right answer to this question. Okay. Moving on to the next question from metallurgy. Galena is a partially oxidized by passing air through it at high temperatures. After some time, the passage of the air is stopped, but the heating is continued in a closed furnace such that the contents undergo self-reduction. Okay, the weight of the Pb produced per kilogram of O2 consumed is. Here they didn't mention what is the formula of galena. Galena is the ore of lead, right? So they are asking to find the weight of lead produced per kilogram of the O2 consumed. So we have to know what is the reaction behind it, right? So galena, that is Pb, yes, it is passing through the air at high temperature. So O2 gives Pb plus SO2, correct? So which means first we are going to find, okay, so first we have to find moles of Pb. So you can see 1:1 ratio is followed here everywhere. The reaction is already balanced. Okay, so if I am finding moles of Pb, which is equal to moles of O2 as well. So moles of O2 means how I can find it out, which is nothing but per kilogram they are asking. So 1000 by 32, correct? 1000 by 32, I'm keeping this as such. Let's see in the end, will that get cancelled or not? Then from here I can find it out, the mass of Pb, isn't it? So mass of Pb, moles of Pb I know. So mass of Pb, which is equal to, what is the molecular mass of Pb? It is given as 207. Okay, so 1000 by 32 into 207, that is mass of lead. So which will become 6.47 kilogram. Okay, I found out mass of lead, that is 6.47. So 6.47 is answer to this question. So you can solve it in this way, or else you can take the reactions and find it out per kilogram as well. Okay, so either way it works, but the question is very simple, but you have to know the reaction from metallurgy chapter. Okay, then the next one, which among the following statements is true for the extraction of aluminium from bauxite? Once again, bauxite is a main ore of aluminium. Okay, the option 1 says the hydrated Al2O3 precipitates when CO2 is bubbled through the solution of sodium aluminate. Okay, then the second option, addition of Na3Al(F6) lowers the melting point of alumina. CO2 is involved in the anode during the electrolysis. And the fourth option, cathode is a steel vessel with a lining of carbon. Okay, so let's see one by one. This is an aluminium extraction process. So this process, which is called Hall-Héroult process, which is a famous process. You must have known about that. This process involved in the Al2O3 is obtained as a precipitate. Okay, so when CO2 is bubbled through the solution of sodium aluminate reacts with CO2 to form sodium carbonate. Along with that, aluminium hydroxide is precipitated out. Okay, so which makes option A is right. And the second option, the electrolytic reduction of this pure aluminium. We will do a electrolysis for purification purpose, right? So electrolytic reduction of this pure aluminium takes place in a steel box. Okay, with a lining of the carbon with cryolite and fluorspar, which lowers the melting point and that will increase the conductivity of the electrolyte as well. Okay, so here they have given the statements. Cathode is a steel vessel with a lining of carbon, and addition of Na3AlF6, it is lowering the melting point of alumina. As I said, what is Na3AlF6, ma'am? That is what the cryolite is. Okay, so which makes B and D is also right. And talking about C, CO2 is evolved in the anode during electrolysis. That is true. At cathode reaction, as a cathode part, Al3 plus is gaining electrons to become Al, and as an anode part, so I'm writing anode part here, as an anode part, carbon takes up oxygen to form CO, and then this C and another carbon is taking up oxygen to form CO2. So CO2, it's a varying amount of electrons involved over here, but anyway the CO2 is evolved at the anode during the electrolysis process. So option A, B, C, D all are right. Let's say this question, the potential of Daniell cell is given. The copper was reported by Buckby, Sardasiel and Metz as E0 value is this much, where T is the temperature in degrees Celsius. Calculate delta S0 for the reaction at 25 degrees Celsius. They are asking at they are telling 1 entropy unit, which is equal to 1 joule per Kelvin. Okay, so only the E0 value is given. So how we can do the calculation and find out the delta S for this question? So we have a simple formula, delta S, which is equal to NF dE by dt, right? Ma'am, I don't know differentiation. I'm telling you in simple words, don't worry. You must have known differentiation because you are writing for maths also. So let's substitute the values first. N, how many electrons are involved? Copper sulfate, zinc sulfate, so obviously 2 electrons. And F value 96,500. And delta E, dE by dt, how we will know about that? So E is a E0 value. We are getting the electrode potential. Here they have given the value of constant and with the variable and T square. So X square and constant are given. So for constant, while differentiating constant, that will be 0. So 0 minus, then I'm having T. So dt by T, dt by dt, which is equal to 1, right? So I'm taking it as such, 6.641 into 10 to the power minus 3. And then I'm having T square. So T square means that will come to further multiplication. So plus 0.72 into 10 to the power minus 5 into 2, right? T. So this is what the value we have. I'm arranging it in the order. Plus comes first, 72 into 10 to the power minus 5. So remaining 2T, 2 into T in minus 0.641. 641 into 10 to the power minus 3. Okay, cool. So this is the tricky part. If you do this well, then answer is easy. So once you have found out this, I'm erasing this, okay? So once you have done this, you can start solving it. So here I'm having 2 into 96,500. While doing this part, I'll be ended up with T for temperature, that is 25 degrees Celsius. So 0.72 into 10 to the power minus 5 into 25 into 250 minus 0.641 into 10 to the power minus 3. So while solving this, I'm getting minus 54.23 joule Kelvin. They are asking it in entropy unit, 1 entropy unit, which is equal to 1 joule per Kelvin. So that will be same as our answer, option D. So option D is the right answer to this question. The differentiation part, that is tricky. That is the main part of this question. Okay. Rest otherwise everything is easy. Okay. Moving on to the next question. For an electrolyte MCl2 in water, 25 degrees Celsius, the following data is given. Okay, the concentration and delta m molar conductance is given, the values are given. They are asking for infinity, molar conductance at infinite distance. They are asking at 25 degrees Celsius. Okay, cool. So we have a simple formula for this, right? So del m, lambda m, which is equal to lambda m naught a c. Okay, so from this what we can do, because we know the concentration, so concentration and lambda m value, so I'm going to substitute it, make it as a 2 equation. So the first one I'm having that as 286, right? 286, which is equal to, what is the concentration for that? 0.16. so lambda not m, that is a, I don't know, that is 0.16, 0.916 while taking root, that will become 0.4. Okay, the second one, this is equation 1. The second one, that is 240 equal to delta m naught a and 1. So 1 while taking root also, that will become 1. So this is equation 2. While solving equation 1 and 2, what will you end up with? 286 equal to lambda m naught minus 0.4 naught minus 240. Correct? So from here you can easily get m naught of, right, 310 as your answer. Okay, so they are asking for lambda n infinity, that is 310. Moving on to the next question. Identify the appropriate graph between enthalpy and progress of physical adsorption. Okay, so this is a single correct answer. Let's see. So we very well know about the enthalpy of adsorption. In case of physisorption, what will happen? It will get increase as in the beginning of the reaction. As the reaction progresses, as the reaction moving forward, the enthalpy will get decrease. So enthalpy decreases as the reaction carried over, progresses, right? So why are you saying that? Because let's say initially, what is the meaning of adsorption? There will be a surface, the particles will get occupied to that surface, but one point of time there will be more particles but less surface, right, as the reaction progresses. So in that case, the enthalpy will become decreases as the reaction move forward. Okay, so just tell me what is the correct answer to this question. So what will happen? First, the enthalpy will be more and then it will get decreases. Okay, option C is the right answer. Then moving forward to the next question. At 1 atm and 273 Kelvin, the volume of nitrogen gas required to cover a sample of silica gel, assuming Langmuir monolayer adsorption, it is found to be 1.30 of the gel. The area occupied by the nitrogen molecule is 0.16 nanometer square. What is the surface area per gram of silica gel? Okay, so Avogadro number, they are asking us to take 6 only. Fine. So let's see. Let's understand the question first. So 1 atm, this is a standard temperature and pressure required to cover the sample of silica gel. We are assuming a Langmuir monolayer adsorption, monolayer only. The found to be 1.30. Okay, so the volume, that is 1.30. The area occupied by the nitrogen molecule is this much. They have given that is in nanometer, but in our options they have given in meters. So be careful about that. They are asking for the surface area. So how we can proceed to this type of question is that nitrogen molecule they have given. So first we can start with number of molecules of nitrogen per gram of silica gel. That is a monolayer adsorption that we very well know about that. So the number of moles, number of moles, which is N by Na, right? So here we are taking that as 6 into 10 to the power 23 and this 22.4, which makes it 22.400 for how much the surface is, volume is, that is 1.30. So 1.3, which will give me 3.48 into 10 to the power 19. Okay. So now we know the cross-sectional area, number of molecules. Next we are going to find the cross-sectional area of the molecule. So cross-sectional area of molecules we are going to find. Then only we can find the area, total area covered by it, right? So cross-sectional area, is it given? Yes. So that is 0.16, which can be converted to 1.6 into 10 to the power minus 19 meter square, because that is given in nanometer square. So I am writing 1.6 into 10 to the power minus 19 meter square. So finally, area, surface area per gram of silica gel. Surface area of per gram, which is 1 molecule per gram, which is equal to number of molecule, that is 3.48 into 10 to the power 90, and cross section, that is area into cross section. So that will give you the answer, isn't it? So the answer will become 5.56. Is it there in the option? Yes, 5.568 meter square per gram. Okay, cool. The next question, 65.6 milligram of sodium phosphate contains 20% of phosphorus 32 and 80% of phosphorus 31 atoms. Assuming only radioactivity of phosphorus 32, if the half-life period of the isotope is 14.3 days, the rate of decay of phosphorus 32 they are asking. Okay, this question combines mole concept and chemical kinetics. Okay, that we are taking only phosphorus 32. Okay, but that amount is not given. We have to take it from sodium phosphate. So 65.6 milligram of sodium phosphate is given. So the moles of sodium phosphate, how we can find? That is 65.6 into 10 to the power 3, because milligram is given. I want it in grams. Divided by, what is the molecular mass of sodium phosphate? 164. So 164 divided by 164, that will give you the value that is equivalent to 1 phosphorus, right? Here I am having only 1 phosphorus. Whatever there in the total amount, that will be there for phosphorus as also, right? So which is equal to moles of phosphorus. So from that, 20% is phosphorus 32. So from here, I have to find out the 20%. So 20% of this value, 6.56 into 10 to the power 3 minus 3, 164. So which will become the moles of phosphorus 32. Correct? Moles of phosphorus 32. So once we have pointed out that, we have to find the number of atoms. So number of atom means what we can do? Just put Na, Avogadro number. Just multiply into Avogadro number to the whole value. Okay, so up to this part, this is from mole concept. The next part from radioactive decay. So that is from chemical kinetics. So we know the simple formula, rate of decay, which is equal to 0.693 by T half, correct? So 0.693, what is the T half value? 14.3 days. So how I can convert it to seconds? Ma'am, why I need to convert it to seconds? Because in the option you can see it is given as DPS, which means days decay per second. Okay, so 14.3 per hour is 24, minute 60, second another 60. Cool, that is for seconds. So the rate of decay we are for phosphorus, this value into, we have to put 0.693, 14.3, 24, 60 into 60, the previous value as well, which is 20 by 100 into 65.6 into 10 to the power minus 3, 164 into 6 into 10 to the power 23 for Na value. Okay, by doing all this calculation, you will be ended up with, why we are dragging this much, because in the last it can get cancelled out. So that's why. So you will be ended up with 2.7 into 10 to the power minus 7. Not minus 7, minus 30. Okay, plus 30. The answer we have given to 27 into 10 to the power 12. Okay. So this can be our answer. Okay. So moving on to the next question. A saturated solution of XeCl3 has a vapor pressure of 17.20 millimeter Hg at 20 degrees Celsius. While pure water vapor pressure is 17.25 mm of Hg, the solubility product. Okay. So here they are asking for solubility product and vapor pressure. Solution chapter along with the equilibrium is combined. Cool. So let's see the first part, which is saying about the vapor pressure. How we can solve this type of question? They are asking for, finally they are asking for KSP. That I understood. So I am taking KSP of XCl3, isn't it? XCl3. So this will be going as 3:1 ratio. So I already told you this type of problem, which will be 27 s to the power 4. 9 into 3, 27. Here I am having 4s, so s to the power 4. Okay, so s value we have to find, then only I can find the KSP value. Okay, so how I can find the s value? How I can find the solubility, molar solubility from the vapor pressure? So P naught minus PS, I mean the pure solvent, and the pressure now, which is equal to I, the Van 't Hoff factor, into N of solute by N of solvent, isn't it? So here I am doing something to make it more easier, where I am going to multiply both the above and below by M solvent into 1000. So N solute into M solvent into 1000. Similarly, here also multiplying into N solvent into M solute, not solute, solvent into 1000. Ma'am, why are you doing this? Right? So here you can say N solute by N solvent into M solvent into 100. Sorry, 1000. No, this is not. So this is our molality, correct? Right? This is our molality M value. Okay, so I'm going to substitute it as I into M into the remaining part M solvent divided by 1000. Okay, cool. So now I'm going to substitute the values of what we have. 17.20 at 20 degrees Celsius, pure vapor pressure, that is 17.25. Okay, so 17. Okay, I don't have space to write. Let me substitute it here. So 17.25 minus 17.20 divided by 17.20, which is equal to, what is the I value? 4 ions will be formed. So 4 into M into M solvent by 1000, right? So what is the solvent here? It is water. So I'm taking that as 18 by 1000, which is, by solving this, you will be ended up with M value. Correct? So the M value, which is approximately equal to 0.04. So M value equal to M, molarity equal to molality. They have given, assumed like that. So molarity, that will be equal to the molar solubility. Correct? So the molar solubility, that is S. So we already know KSP is equal to 27 S to the power 4. So S value, that is 0.04 to the power 4. So while solving that, you will get the answer as 6.9 into 10 to the power minus 5. Okay, option D is the answer to this question. Moving on to the next question. Cl2 disproportionate into Cl minus ions and ClO3 minus in hot alkali. They are asking the wrong statement about this reaction. Okay, this is a disproportionation reaction. Okay, so Cl2 disproportionate as Cl minus plus ClO3 minus. Okay, so what is the oxidation state changes? That is 0 oxidation state to plus -1 and +5. Okay, so what are the options given? Equivalent weight of Cl2 is 60% that of the molecular weight. Okay, so first we have to find the equivalent weight. For that we have to know the N factor. So N factor of Cl2, which is, this is involved in the reduction and oxidation, isn't it? So how many electrons are involved over here? Two Cl is there. So while balancing it, no. So here that will be involving N is equal to 10. And this part, this will give you N is equal to 2. Right? Cl2 to Cl minus, Cl2 to ClO3 minus. Cool. So in that case, it will become N1, N2 by N1 plus N2, isn't it? For finding an N factor. So 10 into 2 divided by 12, which is equal to 5 by 3. So 5 by 3, that is our N factor. So finding out the equivalent weight. So equivalent weight, I'm writing it here. So equivalent weight, we have to use the molecular mass of Cl2. So which is 71, 3 by 5 by N factor. So it becomes 3 by 5. That is 42.6. Okay, 42.6 is the 60% of the molecular weight. Okay, fine. So option A is right. Then moving to the option B. Equivalent weight of oxidized chlorine is 7.1. So the oxidation part, where it is losing the electrons, the N value is 10. So equivalent weight, that is 71 by 10. That is 7.1. Okay. Then the third one, 5 by 6 fraction of total chlorine is reduced. Okay, so for finding out this, I have to balance this equation. So while balancing it, it will become 12 Cl2, 10 Cl and 2 ClO3 minus. Okay, so the fraction of Cl2 reduced from 12 to it became 10. So 10 out of 12, which is nothing but 5 by 6. So C is also right. What about oxidation? So oxidation, once again, which is 2 out of 12. 2 out of 12, which is 1 by 6. but here they have given us 5 by 6, so which is not the correct answer. So A, B, C are only the right answer to this question. The next question, I think this is the last question. A small particle of mass m moves in such a way that P is equal to half 1 by 2 mkr square, where k is a constant, r is the distance of the particle from origin. Assuming Bohr's model of quantization of angular momentum and circular orbit, r is directly proportional to. So if you know the formula, then this is cakewalk to you. This is not a usual formula we are using for JEE Main, that's why I chose this question. What is the magnitude of the force? So we know that they have given that the potential energy which is equal to a half mkr. So the magnitude of force which is equal to du of r by dr, which is equal to mkr. That is our magnitude of force. So this mkr, that is mv square by r, isn't it? So from here we can find it out r value, that is r square equal to v square by k. So we already know for angular momentum mvr is equal to nh by 2 pi, right? So v value we have to know, then only we can solve this. The big formula, n square h square by 4 pi square m square r square, right? So I'm going to substitute everything in this particular equation. So while substituting it, what will I get? So v square value I can substitute, r square equal to v square value n square h square by 4 pi square m square r square by k. Okay, k is there. So from here I can see r, I'm taking it in one side, r to the power 4. Then only it will be whole complete, right? R to the power 4. Then the remaining things will be same, n square h square by 4 pi square m square k. So here you can see r is directly proportional to n, but r to the power 4, which is equal to n square, which means that r is directly proportional to root of n. Okay, so which will be the right answer? Root of n be the right answer to this question. Okay, so hope you got an idea how the questions can be asked. These are some lengthy and difficult questions. Practice more and more questions. Let me know any other videos you need to ace your examination. Thank you.